Hello TechZone students, how are you all? In this video we will study about polynomial regression. In the previous two videos we have studied about simple linear regression and multiple linear regression. Okay, this is the formula of simple linear regression, that is y is equal to b0 plus b1 x1. So x1 was our independent variable, y is our dependent variable. So when we have one independent variable, it's simple linear regression. So what about multiple linear regression? When we have more than one variable, more than one independent variable like x1, x2 and so on. Okay, so what is the formula of multiple linear regression? It is y is equal to b0 plus b1 x1 plus b2 x2 and so on till bn xn. Okay. In this video, we'll study about polynomial linear regression. Okay. But what if we have our data points like this in this form? We have 1 point here, we have 1 point here, here, and so on, right? So this line is not going to best fit this data sets, data points, isn't it? Okay. Because there will be a huge difference, right? There will be a huge difference here. So in this case, this simple linear regression or multiple linear regression will not work. So we go to polynomial regression. Okay. So this is the graph or this is the curve for degree 2 polynomial. See here. Highest degree x1 square, right? Y is equal to b0 plus b1 x1 plus b2 x1 square. Okay, so this is degree 2. All right. So if we go to the other slide. All right. So see, if we have only a constant number like y is equal to 3, our straight line will be like this. Okay, let us say this is 0, this is 1, this is 2 and this is 3, right? So y is equal to 3 will be a straight line. We have only a constant, and what is the degree here? Degree is 0. So 3x power 0, you can write it like this. So what is the degree? Here degree is 0. Okay, if we have degree 1, it will be a linear regression, okay, or linear function like y is equal to 2 plus 3x. So what is the degree of x here? 1. So this is degree 1. So we'll have a straight line. Okay. This is called as a quadratic function. We'll get a graph like this when the degree is 2. Like this, y is equal to maybe 2x plus 3x plus 5x square. I'm just writing random numbers here, right? But this is a degree 2 polynomial. Okay. If we have degree 3 polynomial, a graph will look like this. Okay. So maybe something like this. Y is equal to 2 plus 5x plus 3x square plus 5x cube. When we have a cube, it is a degree 3 function. Okay. And what if we have y is equal to 5x cube? This is also a degree 3 polynomial. Okay, see what is the variable here? Variable here is x. What is its degree? 3. So this is also a degree 3 polynomial. Alright. So this is the graph for degree 4 polynomial. Okay, and this is the graph for degree 5 polynomial. So I just wanted to show you this image. Alright. Now let us go to the Jupyter notebook and write code. So first we'll import all the libraries. Okay. So I'll just expand this. Import numpy, numpy as np. Okay. The next library we'll import is import pandas as PD and matplotlib to draw the plots, right? Import matplotlib dot pyplot as PLT. Okay, we are importing pyplot from matplotlib as PLT. All right. Okay, what we'll do is we'll also import warnings. Okay, so that warnings will be ignored. Warnings, okay, I think it's filter warnings. Yes, filter warnings, okay, ignore. So let me just execute this. All right. Now let us import the data set. I am giving the name as dataset. Dataset is equal to pt dot read underscore CSV. So we are using pandas and using this function read underscore CSV. We are calling the file. Okay. What is the file name? Position underscore salaries. Extension is CSV. Okay. Okay, all right. So let me just print this data set. So this is our data set. Now, what do we have in this data set? See, we have position, we have level, and we have salary. It's a very small data set. Okay. We have position, level, and salary. Based on the level 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the salary is increasing here, right? Based on the level, the salary is increasing. And we have position also here. So we are not going to use position in our polynomial regression. What we'll do is we'll use level and we'll use salary. Okay. All right. So now what we are going to do is we'll separate x and y values now. Okay. So x is equal to data set, that is independent variables and dependent variables. Okay. ilog, we need all the rows, right? We need all the rows and 1:2. Okay. So what will this do? So see here, 1:2 means, see, the index of this will be 0, index will be 1 here, this will be 2. So 1:2 means we are starting from 1. Okay, from 1 to 2, but this 2 will not be included. So indirectly we are saying we need only this level, right? So this will be stored in the value of x, and we'll store the value of salary in y. All the salaries will be stored in y and all the levels will be stored in x. Okay. All right. So if we do it like this, it will be saved as a series. So we need an array. So for that, let us write values. Okay. Let us go ahead and save the values of y also. Y is equal to dataset dot ilog. We need all the rows. Okay. And we need only the second column. Okay. So salaries was the second column, right? And we need that in the form of arrays. So I have executed that. Okay. Now let us go ahead and print. See what is there in x. We have only the levels 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do we have in y? We have the values. Okay. We have the salaries, in fact. Okay. So what we'll do now is we'll plot a scatter plot between x and y. Okay. So plt dot scatter x comma y. Okay. Let the color be red. Okay. Let the color be blue. Okay. So as you can see, these points are not linear, right? These points are not linear. So we cannot draw a straight line, or our linear regression model will draw a straight line, and that will not work for this data set, isn't it? Because these points are not linear. Okay, these are what? They are curved, right? We need something like this. We need a line like this. Okay, so polynomial regression will work for this data set, isn't it? Linear regression will not work, polynomial regression will work. Okay, all right. So what we'll do is, we'll first implement linear regression. Okay, we'll first use linear regression, and I'll show the difference, and then we'll do polynomial regression. Okay, all right. So for that, what we are going to do is, first we need to split our data set into training and testing, right? So for that, let us use sklearn. So from sklearn model selection, we will import train, test, split, split, split. Okay, and we'll store the values in xtrain and xtest, ytrain, ytest. Okay, and we'll use this train test split. Okay, and copy here. Okay, and this train test split method will accept x and y values, and let the test size be 0.2, which means 20%, right? And let the random state be 0. Okay, so we took test size as 20%, which means training size will be 80%. Okay, training size will be 80%, and this test size will be 20%. So 20% means 0.2, and the random state is equal to 0, which means whenever we are executing this, the same rows will be considered. Okay, all right. So now let us go ahead and execute this. All right, so let us just check what is there in xtrain. Okay, so these are the values in xtrain. The level, see, randomly it has selected, right? So randomly it has selected 8 values. So 80% of 10 will be 8 values, right? Okay, after that, let us go ahead and check what is there in x test. So 2 values will be given, right? So 3 and 9. Okay, y train, so 8 salaries here, and y test 2 salaries. Okay, all right. Now what we need to do here is, see, we are going to scale the values. Okay, we are going to transform these values. Why are we transforming these values? Because when you see this, see, levels are 1 2 3 4 5 6 7 8 9 10, and the salaries are in thousands, 45 50 60 80 and so on, right? So machine learning will think that the salaries are very important. The weightage for the salaries will be high. Okay, and the weightage of these levels will not be that important. So machine learning will think that, but we know the levels are also important, isn't it? So what we'll do is, we'll scale these values. Okay, we'll transform these values, and the transformed values will be on the same scale. Okay, all right. So let us transform the values. For that, from sklearn, okay, and from pre-processing, we need to import a standard scaler. Okay, and standard scaler of x values. So I took that as sc underscore x. Let us use the standard scalar. Okay. And x train sc underscore x dot fit underscore transform. Okay, we are going to transform x train values. So this fit underscore transform will transform the values of x and it will fit. Okay, it will do two things at once. X test values also we need to transform. Sc underscore x dot transform x underscore test. Okay, let us execute this. All right, now let us go ahead and print the values of x train. See, these are the values of x train now. So these are the transformed values. See, they are different now, right? X test. So these are the transformed values of x test. Now what we'll do is we'll fit linear regression to our data set. Okay. So for that, from sklearn again, from sklearn we need, from linear model we need to import linear regression. Okay, and let that linear regression be lin underscore reg equal to linear regression. Okay, we have initialized, and let us fit linear underscore reg is equal to not is equal to, it should be fit. We need to fit the values of x comma y. Okay. All right, it is initialized, right? Now what do we need to do is, let us predict the values and store that in ypred. So y underscore pred is equal to lin underscore reg. We are using this lin underscore reg. Okay, dot predict. So this predict method will predict the values. Okay, and let us print this. So these are our predicted values. Okay, these are our predicted values. Now what we'll do is, we'll visualize the linear regression now. Okay, that means we'll draw the graph and see. So plt dot scatter. Okay, x comma y, and color is equal to, let us say, red. Okay, the points will be in red color, and plt dot plot. Okay, x comma y underscore pred comma color is equal to some blue. Okay, okay, and then plt dot show. Okay, I'm not going to write titles and all. So see here, what is this? See, these are our data points, x comma y, right? And this is our predicted line. Linear regression has predicted, but as you can see, this is not the best fit line, right? Or this is not the best fit curve. Okay, we should have had something like this, right? But we got a straight line which clearly states that, which clearly shows that linear regression will not work for this data set. Okay, because our data set is not linear. Okay, I'll show you. Let us predict some value, right? Let us predict some value. What was that? Lin underscore reg dot predict. Okay, so what we'll do is we'll give some value here, like maybe 6.5. okay, and execute that. So see, when we have implemented linear regression and we gave the position as 6.5, level as 6.5, it predicted that the salary should be 33,000. okay, 33,000. Let us go ahead and see the database. So see, 6 and 7 is here, right? So 6.5, it showed that our salary should be 33,000. For 6.5, the salary should be around 33,000, right? 33K. But we can see that for 6.5, it should not be 33,000. It should be somewhere between 15,000 and 20, isn't it? 15 and 20. Okay. So this linear regression model is not doing a good job in our case, isn't it? So what should we do now? We should implement polynomial regression. So let us go ahead and implement polynomial regression now. So from sklearn dot pre-processing, we will import polynomial features. Okay, we'll import polynomial features and let that be polynomial reg. Okay, I'll just copy paste this polynomial features. All right, and degree, let us take it as 2. okay, first let us take degree as 2, degree is equal to 2, and we'll draw the graph and check. Okay, we can change this degree, we can give degree as 3, 4, 5, anything we like. Okay, later on we'll change this value. Okay, now x polynomial values. Okay, x polynomial values. Okay, poly underscore reg. Okay, so what we'll do is we'll fit underscore transform. So what we did for linear regression, we are doing the same thing for polynomial also. Okay, poly underscore reg, and we are going to fit the values of x underscore poly comma y. Okay, okay, let us execute this. Poly underscore fit transform. Okay, we got an error here. From sklearn pre-processing import polynomial features, poly underscore reg is equal to polynomial features, poly underscore reg dot fit underscore transform. Okay, spelling of transform was wrong. Okay, okay, so we have executed this. So len reg underscore 2, because len underscore reg was for linear regression, so we took len underscore reg underscore 2. Okay, linear regression. Okay, see, polynomial regression is also a part of linear regression. Okay, so len underscore reg underscore 2. Okay, dot fit, we are going to fit x poly value, x comma y values. Okay, all right, so polynomial features and linear regression features, okay, are here now. Let us visualize this polynomial regression. What I'll do is I'll just have few more cells. Okay, so plt dot scatter x comma y, color is equal to red. Okay, color is equal to red. Y underscore pred. Okay, this we are going to predict the values now. Y underscore pred, let that be some line underscore reg underscore 2 dot predict. Okay, so x underscore poly, right? So for x underscore poly, we are going to predict the values, and then we'll plot that. plt dot plot x comma y underscore pred. Okay, and the color, let the line color be blue. Okay, I'm not giving titles and all. Alright, so see, this red points were our data sets, right? Data points, and this is the predicted curve. So when degree was 2, our polynomial regression has drawn this curve. Okay, it is better than the straight line, isn't it? We had a straight line like this before, so it is better than that, isn't it? So what we'll do now is we'll go ahead and check the performance. We'll give some random value and check whether that value is accurate or not. Okay, so here also poly underscore reg will fit underscore transform. Okay, some 6.5, right? We give 6.5, so I'll just execute this. Okay, poly underscore reg dot transform, spelling of transform, right? Okay, all right, so see here, 1,89,498. Okay, so when you go back to our data set and check, so 6.5, so see here, 6.5 is will be here, right? So our model predicted that we need some, our model predicted that we got 18, right? So see, when you see this, see 6 and 7, for 6 it is 15, for 7 it is 20. We give 6.5 value and our model has predicted 18, right? So slightly better than linear regression model, right? Isn't it? A lot better, in fact. Okay, so this is how we will implement polynomial regression. What we'll do is we'll actually find R2 square or R2 score. Okay, let us go ahead and find R2 score also. So from sklearn, okay, metrics, we will import R2 score, R2 underscore score. So R2 underscore score for y and y predict will be equal to how much? See, 91%, 0.91 is 91%, right? So what will happen if we change as to, okay, let us go ahead and change the degree. So let the degree be 3. I'll execute this, okay. So see here, our graph is slightly better now, it is slightly bent here, okay. And see the performance 90, wait, I did not execute this, 98%, right? It has increased. So what we'll do is we'll just change the degree to 4 and see, degree is equal to 4. Execute, okay, execute, 99.73. okay. See, you might be thinking that this is very good, our model is doing a very good job, but this is the case of overfitting. Okay, overfitting is not good. This is the case of overfitting. Overfitting is bad, very, very bad. Okay, we'll learn about overfitting, underfitting, okay, bias and variance in the future videos. Alright, so I think the degree 2 will work here. So let the degree be 2. Alright. So this is how we'll implement polynomial regression. Thank you so much for watching the video.